Good morning. We're going to talk about the concept of linearization in calculus. The idea is, suppose you have some function. Linearization is essentially a fancy name for the tangent line. But this is an extremely useful concept in calculus that's used in the sciences. If you have a function that's differentiable, say at a point A, oops, it's not very straight, then you already know that the derivative tells you the slope and the point give you a tangent line. Right? So the slope of this line, if this function is called f, this is f prime at A. And then we've got some little dashes over here to f of A. And you can find the equation of that line just using algebra. Now if you look in here, this line does a pretty good job for a certain chunk of the curve of approximating it. And that's the real idea. The tangent line is approximately equal to f of x for an interval around A. So you can imagine in this picture not being very rigorous, but there's some collection of numbers that this makes sense to do. Now this is a weird concept for most students the first time. Why would you have to do this? We have computers and calculators. Just plug the numbers in. The real place that linearization pays off, and you'll see this in some further videos, is in differential equations, is in using calculus in the sciences. Not computing what f equals for a certain number, but rather how to use the function f in an application. So this you'll see in calculus books, they'll give you an equation for this. You don't really need it, but here's the idea. If your tangent line, say y sub t, is mx plus b, then you know what m is. So we already have that. That's the derivative. Now, how do you find b? Well, you just plug in some x and some y on the line. Well, we have that. So y is f of a when x is equal to a. There's plus b. You can solve this. You'll have f of a minus f prime of a times a equals b. Put it all together, and you have your tangent line is f prime of a x plus f of a minus f prime of a times a. And it usually gets kind of combined, and you'll recognize this as the point-slope form of a line. Not that that name is very important. And also, they'll usually change the label. You might use an L or something. So the linearization of the function f at A is this thing. But this is just the tangent line. All right, so a quick summary. The idea of linearization is you have a function. It's differentiable at a point over and on an interval around that point. The tangent line does an okay job depending on approximating it. Now, just a quick follow-up. It doesn't do the same job everywhere. Let me just show you a couple ones here. For example, this tangent line, it's got a little chunk of space, but it starts falling off pretty fast. The error is quite large. Compare that with, say, a tangent line right here. This tangent line works really well over this big interval. The tangent line looks just like the function right here. It's okay right here, and it's not very good right there. We'll talk in a later video about how we can tell when.